So, in the last lecture we had seen how a structure is defined. Now, we will see more examples of that in the course. So, today we will be concentrating on how a particular structure can be processed. In order to process a structure, we have to process every field of the structure. We can operate on every field of the structure. So, we can see that a structure, how can we access the member of a structure? Say for example, there is a variable like name. So, we can say the overall name of the structure is say student, all right. And in the inside student, we have got name, roll number, etc. Now, I can, so my variable is say, all right, let me say I have defined like this struct student, then all these, then the variables are A1, A2, A3. I am sure you are getting confused a little bit. So, let us define it in the proper way as we had done in the last class. Suppose I define struct student char name 10 int roll number, all right. Suppose only two fields are there, and I also say that the variables are x1 comma x2. These are two variables of the type of this structure whose name is student. So, what is my variable name? x1. So, here I can say x1 dot, this is the dot operator which tells about the member. Now, which member? Say I want to get the roll number, x1 dot roll number assign 720, all right. So, this is how I can get access to a particular member of a particular structure. So, I can also similarly write x2 dot name, because the member's name is name, right, name 3 is J, all right, because name has got a 10 field character. Okay, I could have written x2 dot name and I could have assigned a string to this. All these are possible. So, if this is clear, then we go ahead a little bit, where variable refers, this variable is referring to the name of a structure type variable, and member is the referring to the field or the particular member element. Okay. The examples are A1 dot name, A1 dot roll number, A3 dot date of birth, etc. So, now here let us take the old example that we had seen, that is a complex number, and how we can perform complex number addition. Now, just to refresh your mind, say I have got two complex numbers x and y, and I want to perform x plus y. Suppose x is a plus ib and y is m plus in, then x plus y is, the real parts are added separately. So, it is a plus m plus I, then the imaginary parts are added separately, b plus n, that we know from our school level knowledge. Now, how can I perform this addition using the the concept of a structure. So, here you see in the program we define a structure called complex, and there are 3 variables A, B and C of this structure type of type complex. All right. Now, what are there? The components are, one is float, one is real part, another is, I should rename this. This is actually the imaginary part. Okay. It is renamed in this way here in this program. It would have been better if I had written float real part, float imaginary part. However, now scanf, I am reading the 2 numbers. A is a variable, A's real part is being read and A's complex part is being read. Note the format statements, because both of them are float, we are putting %f, all right. And so, I read A. So, you see, normally I would have just done scanf ampersand A, but here I have to do separately, I have to read the real part and the imaginary part. Then the sum is being stored in C. So, C is real will be, C is the sum. So, its real will be, its real part will be the real part of A plus the real part of B, and the imaginary part, or the, as it is written here, complex part, is the complex part of imaginary part of A plus the imaginary part of B. Then I am printing, look at how I am printing it, printing %f, the real part of C, and plus, then I put J and then the complex part of C. So, what is being done is, suppose I have got 2 numbers 3.4 plus, here I am using J, some people, I usually use I or J, whatever you do. So, you write 7.2, that is A, A's real part is this, and B's real part is say 4.6 plus J 3.8. Now, if I add them, C will be, these real parts are being added. So, it is 8.0 plus the imaginary part is added, that is 11, J11. All right. So, what will be printed is 8 plus J, then the complex part 11.0. So, this is I think this is clear to you, this is not very difficult to understand. Let us move ahead. So, you have seen here, if you note here, you have got the structure definition specified, and here the variable definitions, and here we are doing the reading and adding them part by part. How am I accessing the members? I am accessing the members using this dot operator, and whenever I am reading the member, I am actually reading the members, I am not reading the structure as a whole. Now, one thing to note is, when I am declaring this structure inside the main, then the scope of these variables, real and complex, etc., or this structure as such, is its scope is within the main. So, if a structure is defined within a function, then as we exit that function, the life of that particular structure will end at that point. Now, there are some things which we can do in a much more simpler way. You remember that in the case of arrays, we could not compare arrays together, that array A1 is equal to A2, that was not possible. If we had to compare an array, I had to check them element by element. On the other hand, in the case of a structure variable can be directly assigned to another structure variable of the same type. For example, here if A is a structure, then I can assign another structure B to it directly. So, all the elements, if they are of course of the same type. So, here is one structure, here is another structure. Now, if I do this operation, that means assignment, then this will be copied here, this will be copied here, this will be copied here, this will be copied here. All right. But if A and B were arrays, in that case, that would not have been possible, that A is an array and B is an array. So, the elements, just by assigning A assigned B, I could not assign B elements to A. That is not allowed in the case of an array. However, that is possible in the case of a structure. Secondly, now here one important thing is that they must be of the same type. All right. Otherwise, of course, the members and the fields will not match. So, A1 assigned A2 I can do. All the individual members get assigned. Two structure variables cannot be compared for equality or inequality. Now, this is important, that two structure variables, I cannot compare them. That structure A1, whether that is equal to A2, that we will have to do compare. I mean, what I said just a couple of minutes back was inadvertent, that is wrong. Structures we cannot compare, we can assign in a short, but comparison of structures we cannot do as a whole. All right. Two structure variables cannot be compared for equality or inequality. Now, for that, what we have to do, we can write a simple function. Say I can write, and you can take it as an assignment, that we can write struct CMP, where you will take two structures as input and you will compare them. And how do you compare them? You will do, say, variable A1 dot member 1 equals to, is whether if it is equal to variable A2 dot member 1. In that way, if you do, then it is possible. So, what we can do here is, I have got two structures, and there are two variables of the same type, of the same structure type, one is A1 and one is A2, and I have got some values here, all right. And say this is member 1, member 2, member 3, member 4, like that. Now, in order to compare, if I want to compare them, what I have to do, I will have to see if this is A1, A1 dot M1 is, this is also M1, is equal to A2 dot M1 and A1 dot M2 is equal to A2 dot M2 and so on and so forth. If I do, then return 1. That could be my function. That means, if all these are matching, then only I will say that they have been compared to be the same. Otherwise, it will return false. So, here else return false. So, you have to write it nicely. You can take it up as an assignment. Arrays of structures. Now, once we know this, we can now make an array of structure. Why is that useful? Let us take one problem. Let us say that I am trying to store the information of a class of students. Where maybe there are, say, 40 students. And their information about each student has got different components: name in a particular class, roll number, and say marks, total marks. So, marks is an integer, let me say. Roll number is also an integer, and name is a character array. something. All right. Now, so this box, this can be also depicted as a box having 3 fields: name, roll number and marks. But I want to have that for all the 40 students. So, I will have 40 such small boxes, each having 3 fields, one after another. So, that can be represented as an array. You know that in an array, we can store data of only the same type. So, that is not causing any problem here, because each of these boxes are of the type struct students. Therefore, I can very well consider them to be an array of such structures. So, if I call this class is this array, then each of these boxes are an element of that array. So, if I say class 0, which element am I looking at? This element, right. If I take class 0 dot name, then which field am I looking at? This particular field. If I write class 2 dot roll number, which field am I looking at? Class 2. So, it is an array 0, 1, 2. You know that just in C any array starts with 0. So, 0, 1, 2, I come over here, and which field am I looking at? Roll number. Roll number is the second field. In that way, I can access each element of this array either as a structure or as an individual member of that structure. All right. So, in such cases, or the same thing could be applicable if I want to represent a library. So, in that case, what will happen? A library will consist of books, right. So, suppose it is a small library where I have got a library of 20 books, all right, 20 books. So, books is an array of type what? Or let me name it different way. So, I am saying my library is consisting of 20 books at most. And what is the type of library? When we write any array, we write int A20, float A20, like that. So, here what is the type of library? Type of library will be struct book. So, because every element of this library, when I write int A20, that means I am talking of an array where there are 20 elements and each element is of type int. So, when I am talking of this struct book library 20, what will that mean? That will mean that here is an array library having 20 such field, 20 such positions, elements, and each element is a structure called book. I have not defined here the structure of book. So, I should have done it earlier. Suppose I do here struct book char name 10 semicolon, that is the name of the book, char author 10, the author of the book, int ISBN, and I close that. Suppose this is a structure of the book having 3 fields only. It could have been more fields, number of pages, year of publication, etc. I am not showing that. So, each of these elements have got 3 fields here: name, which is itself an array of 10 characters, author, which is itself an array of 10 characters, and an integer ISBN number. So, this is the whole element, the first or one element of the array library, and library is an array which houses 20 at the most such individual structures. So, if I say library 3 dot ISBN, where am I going? Which one I am referring to? 0, 1, 2, 3. Library 3, and the last element of that, this is the ISBN number, because that is the last one. All right. So, therefore, using structure allows us to store different types of data together. And again, array of structure is a very powerful facility that has been given to us, using which we can store many more things and we get much more flexibility. Let us go here. Once a structure has been defined, like the structure book that was defined, we can declare an array of structures. For example, struct student class 50. So, note here that class is an array having 50 elements. So, it is something like this. Here is class with 50 elements, 0 to 49. And what is each element? Each of these elements is a structure of type student, must have been defined somewhere earlier. Okay. The individual members can be accessed by class, whichever element I want to have. Say for example, struct student, one field is int roll number, there is a name, there is marks and character. So, this is the student and I have got 3 variables A1, A2, A3. The array element within the structure, and I have defined an array earlier, that is a class of 50, right. So, now I have got an array of which every element is a structure like this, and the structures are variables A1. These are also the student variables. Also, my class is consisting of the same structure. The array element within the structure can be accessed as, now you can very easily guess, if A1 dot marks 2. Now, here this example is telling us something more. Here this example is showing that any element of a member of the structure student can also be an array that we had defined earlier. This is also an array. Now, suppose I have got this student A1, his name is A, roll number is say 1, and marks is itself an array where the marks of literature, history, geography, maths, science, everything is stored, and the date of birth is a character array. All right. Now, so it is say 07 07 2007. So, that is a character array. Now, when I am saying A1 marks 2, that means I am going to, this field is the marks field. I am going to the A1 structure, A1 variable, and I am taking its structure and coming to the marks field or membership. member, and I am coming to the element 0, 1, 2, this particular element. This particular element I am coming to by this. This you must understand. Okay. So, I can have an array within a structure, also I can have an array of structure. Till now what we are discussing was, and here what we discussed was an array of structure, right. And here what we have just now shown you is an example of that an array can also be a part of a structure. Next lecture we will be talking about a new thing that's also very important, typedef. That is very much useful for that facilitates us to create new type definitions, and we can write much simpler programs with this. We will take it up in the next lecture.